Okay, for topic two, we're going to start looking at the equations of hyperbolas. Whoa, that's the wrong pen. Okay, we're going to look at the equations for hyperbolas. All right, and we're going to do like we did in the previous two sections where we look at, in this case, a hyperbola that's going to be centered at the origin. And then in the next video, we'll look at hyperbolas that are centered elsewhere. Okay, so in the event that you do have a hyperbola centered at the origin, okay, we know that we can have hyperbolas kind of facing or opening two different directions. You can have a situation where your hyperbola is opening kind of facing the x-axis, so like opening in like sort of the x direction, or you can have a hyperbola that is opening more like in the y direction, okay? So we have to know like what to look for, okay? So the standard form equation for a hyperbola is this right here, okay? And I want you to be very, very careful. This looks very similar to the equation, the standard form equation of an ellipse centered at the origin, but there's one really big difference, and it is this right here. So just kind of remember that when we're dealing with hyperbolas, we're doing subtraction. So we're looking at the distance from one focus point to a point on the hyperbola, and then from that point, the distance from there to the second focus, and then like the difference between those. Remember, we're subtracting those distances, and we found that that's always going to be a constant distance of plus or minus 2a. Okay, so just kind of think subtraction hyperbolas. Okay. So the other thing that you have to be very mindful of is which term comes first. Do we have our x fraction, our x term, or do we have our y fraction, y term first? So when you have the x term as your positive, so the x term is positive, that is where your transverse axis is going to be some horizontal axis. In this case, it's going to very specifically be the x-axis. If you're centered somewhere other than the origin, you're just going to have some kind of horizontal transverse axis, okay? Now, if on the flip side of that, the y term is the one that is positive, then you're going to have a transverse axis that, in this case, when you're centered at the origin, is along the y-axis. So this means you're going to have some kind of vertical axis, whereas if x is the positive term, you're going to have a horizontal axis. So that kind of tells you how your hyperbolas are opening, all right? And then further, we have those a's and b's again. So just like with ellipses, just like with parabolas, we have these A, B, C's that we're dealing with. Well, really more so the ellipses. We have the A's, the B's, and the C's, and we had some kind of Pythagorean relationship. We have the same thing here, okay? You can see the denominators of the X and Y terms are A squared and B squared again. So we need to make sure we understand what these values are, okay? So A is the distance from the center to the vertices, like the main vertices, the ones that are like along your transverse axis. Okay. B is the distance from the center to the co-vertices. Now remember, the co-vertices are on the conjugate axis, which runs perpendicular to the transverse axis. They're kind of in the opposite direction to co-vertices. And then over here, we're going to say C. We haven't talked about how to get C yet, but C is the distance from the center to the foci. Okay. So we need to find a way to find what C is. And remember, in the previous section where we were talking about the ellipse, we had this Pythagorean relationship. We have a Pythagorean relationship here, okay? The Pythagorean relationship is a little different though. So the Pythagorean relationship this time is c squared equals a squared plus b squared. So it's kind of more typical, like what we expect with a Pythagorean theorem. And the reason we can justify this is if you go back to, where's my mouse? If you go back to some of those previous examples, like this one right here, or this one here. Let's look at this one. This one's a little bit better. We had values for A, B, and C, right? Well, C is the longest of those distances. So if we were to create some kind of a right triangle here, the longest side would end up being side C. So that's why we're going to get the C squared equals A squared plus B squared. Okay? So just be really, really careful with your Pythagorean relationship. C is the biggest. So that's why we get the C squared equals A squared plus B squared. And I have that written out here. Okay. So A, B, and C are going to represent the same things, even if your hyperbola is opening in the opposite direction. We just have to be really, really careful. A is still going to be the distance from the center to the vertices, but this time your vertices are going to be running kind of along that y-axis. Okay, so we're going to be kind of playing around with our y's instead of our x's. B is going to be the distance from the center to the co-vertices, which is going to be running along that kind of like the x-axis, and then the foci, those are going to be along that vertical axis again. So A, B, and C represent the same thing. They're just going to be in different locations from one version of a hyperbola to the other. Okay, so let's go ahead and look at some examples. And please remember, the Pythagorean relationship for a hyperbola is the typical Pythagorean theorem. C squared equals A squared plus B squared. Okay, so for example one, it says write each equation in standard form. Okay, so we want them to be looking like these where they're equal to 1. Okay, and then it says graph the hyperbola, label the vertices and the foci. So we're going to do the main vertices, we're going to do the co-vertices, and then we're going to do the foci. Okay, so those 2 focus points. All right. So in order to put this first equation, we have 8x squared minus 2y squared equals 72. In order to put this in standard form, we need to get this equal to 1. And the way we can do that is we can start by dividing everything by 72. Okay, so what that is going to do is when I reduce all of these fractions, the 8 is going to reduce the 72 to a 9. So I'm going to get x squared over 9. And then the 2 is going to reduce the 72 to a 36. So I'm going to get y squared over 36. And then 72 divided by itself is just 1. We now have standard form. And we're definitely dealing with a hyperbola. And I know this because we're subtracting. Okay? So let's just take a really quick moment and acknowledge what A and B are, okay? And then we can figure out what C is, and then we can find the vertices and the foci, okay? So let's talk about A. So A squared is given to us. In this case, A squared, let's always say it's the value that's under the main term, the positive term, we'll say. So in this case, X is positive, which means the parabola is going to open kind of along the X axis. It's going to open up facing the direction of X, okay? So we know that the transverse axis is horizontal. All right. So now that we know that, let's go and find A, B, and C. Okay. So A squared is going to be the term or the denominator under your first term. So A squared is 9, which tells me that A is 3. So we just want the square root of 9. Okay. B squared is going to be the denominator under the second term. So in this case, y squared over 36. So B squared is 36, which tells me that B is 6. And C we don't know, but we have enough information to get C. Okay, so remember, C squared equals A squared plus B squared. So if I wanted to solve for C, just to kind of get like a shorter, quicker formula to use, I would just take the square root of both sides, and I would say, well, C then has to be the square root of A squared plus B squared. So in this case, C is going to be the square root of 36 plus 9. Well, I guess it would technically be 9 plus 36. So C is the square root of 45. Or if we want to get kind of, if we want to like plot these points that are going to involve a C, we may want to estimate and see what C is as a decimal. So we would end up getting that C is approximately 6.7. So first you could simplify this to 3 square root 5, and then that would simplify to approximately 6.7. Okay, so keep all of these values in mind. We have A, we have B, and we now have values for C. Okay, so let's talk about the center, the vertices, and the foci. Okay, the center is easy. If you have just x squared and y squared without anything being added or subtracted, from just that numerator, you know you're dealing with something centered at the origin. So the origin is our center. Now let's talk about the main vertices. Okay. Now what we're dealing with in this case, because the x term is the positive term, we're going to have a parabola that's doing something kind of like that. All right. So let's think about what that's going to mean for us. Okay, our center is right here. Because we're going to have these curves of our parabola opening kind of towards the x-axis, that means we need to play around with our x-coordinate of our center to figure out what our vertices are. So in this case, the vertices are going to be at h. Remember, h is the x-coordinate of your center, and we're going to go plus or minus a. And then the y coordinate is just going to be k. So that is remembering that the center is always technically hk. So what are we subtracting from x? That is h. What are we subtracting from k? Or what are we subtracting from y? That is k. Okay? So we already know that h is just 0. Okay? So we're going to get 0 plus or minus, well, what was a? It was 3. So we're going to get 0 plus or minus 3, comma, 0. So the main vertices are going to be negative 3, 0, and 3, 0. So we have our center, and we now have the main vertices. Okay, let's talk about co-vertices. Now, the co-vertices run the opposite direction. So if your vertices are going to be horizontal, they're going to be on that horizontal transverse axis, then the co-vertices are going to be along the vertical conjugate axis, okay? So that means we're going to have to play around with our k, our y coordinate here, so the k value of our center. So the co-vertices are going to be at h, comma, k plus or minus b, okay? So we want to go plus or minus b, which was 6 in this case. All right, so that means h is just 0. K was 0, but we're going to go k plus or minus 6. So our co-vertices are going to be at 0, comma, negative 6, and 0, comma, positive 6. So those are the co-vertices. And then last up for us would be the foci. We're just about out of room, so we got to be really, really careful here. So for the foci are going to run along the transverse axis. Since we have a horizontal transverse axis, we need to play around with the x-coordinates of our center. We can base everything off our center, okay? So we're going to say the foci are at h plus or minus c. C is the distance from the center to the foci, comma, k. So that means we're going to be at 0 plus or minus c, which we're going to just estimate to be 6.7. Comma, 0 for k. So our foci are going to be negative 6.7, comma, 0, and positive 6.7, comma, 0. Okay? So that's the really important points here. So let's go ahead and sketch this. We've already got our center, okay? Let's take just a moment and show some appreciation to the transverse axis. So if you're centered at the origin, your transverse axis is going to go through your center, as is your conjugate axis. Since we're centered at the origin, the x-axis is the transverse axis. So this is the transverse axis. And then the y-axis is going to be the conjugate axis. Okay. And then what we need to do is we need to plot the vertices, and we're going to draw this special box, and then we're going to plot the foci as well, and then we'll build the curves, and I'll kind of explain how that works. Okay. So let's see. Our vertices are at negative 3, 0, and at 3, 0. Our co-vertices are at 0, 6, and we are really out of room here. 0, whoops, negative 6. Okay. And then the foci are at negative 6 points. Did I have that right? Negative 6.7. I do. So they're going to be like over here and over here. Okay, so let's see what these curves are going to look like. Here's how you build this rectangle. The co-vertices seem kind of pointless. They're not even like points on the hyperbola, but here's what you do with it. You build this rectangle. So you go up from your main vertices or your co-vertices, depending, and then you go across. So you build a sketch of a rectangle that goes through all of your vertices. Okay? And then it turns out that hyperbolas are asymptotic. They have asymptotes. So the asymptotes run corner to corner. I need to scroll down just a smidge. Okay, so they run corner to corner. Pretend that was pretty and perfect. So the asymptotes are, they're kind of like invisible lines that your graph's not going to cross. So they're going to go through the center and then through the corners of that box. And then we use that as our guides to build our curve. So we know that the vertices are going to be points on the graph. Woo. Don't draw it like that, y'all. And there we have it. Yay! Now in the next example, maybe. Yes. So in topic 3, we're going to look at how to actually find the value of the asymptotes. For now, we're just going to use them to sketch. Okay. So let's see what we can do for the next example, or not the next example, part B. So for part B, we have 9x squared minus 16y squared equals 144. We want to put this in standard form, which means divide everything by 144. So that is going to give me the standard form equation of x squared over 16. 9 will divide into 144 16 times, so that's going to reduce. Minus 16 goes into 144 9 times, so minus y squared over 9 equals 1. So that is standard form of the equation. Notice the x term is positive, which tells me the transverse axis is horizontal. Okay, so we know we're going to have, since we're going to be centered at the origin here, we know we're going to have the x-axis as our transverse axis again. Okay, now the center, we know we're at the center because the numerators, that x squared isn't like x minus or x plus something squared, same thing for the y. So our center is going to be again at the origin. Okay, we need to figure out what a and b are. A is always going to be the denominator of your positive term. So we'll say, okay, well, a squared is 16, which means that a is the square root of that. So a is 4. B squared is 9. So the square root of that is b, which would just be 3. Okay, we need to do a little work to find c. Okay, so remember, there is a Pythagorean relationship here, and it is c squared equals a squared plus b squared. And in the previous example, we did a little work and we're like, okay, well, we can just say that c is the square root of a squared plus b squared. So c is the square root of 16 plus 9, which is 25. So we can say that c is equal to 5. So we have found a lot of really, really helpful information. First, we have the center. We know that the transverse axis is going to be horizontal through the center, which means it's just going to be the x-axis. We now need to find our vertices, main and co-vertices, and then we're going to find the foci. So vertices, we know the vertices run along the transverse axis. And since the transverse axis is horizontal, that means we need to play around with our x coordinates of the center. So remember, we generally say the center is at h comma k. So we need to play around with those h values of our center. So we want to say, okay, our vertices are going to be at h plus or minus a. Remember, a is the distance from the center to the vertices, comma k. Well, that means since h is 0, we're going to get h plus or minus a, which is 4, comma k, which is 0. So our vertices are going to be, let's see, negative 4, comma 0, and positive 4, comma 0. Okay. Now the co-vertices, remember, they run along the conjugate axis. So if the transverse axis is horizontal, the conjugate axis is going to be vertical. So that means we need to play around with the y values of our center. So the co-vertices are going to be a very specific distance from the center. In fact, they're going to be b units away from the center. So we want to say, okay, well, our co-vertices are going to be at h, comma, k plus or minus b. So 0, comma, 0 plus or minus 3, that's our b. So our co-vertices are going to be 0, negative 3, and 0, positive 3. So we've got our co-vertices. And then that leaves the foci. Now, the foci also run along the transverse axis. Since our transverse axis is horizontal, we need to play around with those h values, the x coordinates of our center. So we're going to get h plus or minus c, comma, k. So that's going to be 0 plus or minus 5. Remember, c was 5, comma, 0. So the foci will be at negative 5, comma, 0, 5, comma, 0. All right. Let's plot this, draw our little rectangle, and get our curves in, okay? So we've got our center, it's at 0, 0. We have our vertices, which are at negative 4, 0, and 4, 0. The foci are at negative and positive 5 on the x-axis. And then the covertices are at negative 3 and positive 3, okay? So we're going to sketch our little rectangle, and that's going to go from, it's got just an X that goes through all the vertices. So we're going to go, this doesn't have to be perfect necessarily. Like I'm not looking for actual perfection because in a minute I'll show you how to find the technical asymptotes, but this does help us build, it kind of helps us sketch where the asymptotes are to help us draw our curves a little better. So the asymptotes go through the center and then they go through the corners of this. So we're going to have asymptotes doing this and this, and now we can draw those curves. Whoopsie, that one got a little out of hand, y'all. And that's it. Yay. So you can go in and actually label the vertices, the foci, if you'd like to. So this would just be negative 5, 0. This would be negative 4, 0. This would be 0, 0. This would be 0, negative 3, 0, positive 3, 4, 0, and 5, 0. And that's it. That is graphing a hyperbola. Now you could sketch this a lot easier, okay? But you will be expected on your final exam to find the actual points for vertices, foci, and all that stuff, okay? So I think that's it for this video. Yes, in the next video, I will show you how to officially find the equations for the asymptotes. They're just going to be equations of lines, okay?